All right, section 2.8 is titled Graphing Linear and Absolute Value Inequalities. So we'll be using inequality signs instead of equal signs. So we're just going to jump right into some examples. So graph. So number one, I'm going to give an equation. And I'm going to go ahead and let's go with an equation that's in slope-intercept form. Y equals negative 2x plus 3. As I go to graph that, it has a y-intercept of positive 3. And slope is negative 2, so that's like negative 2 over 1. So go down 2 over 1. Okay, we know it's linear. If it's linear, 2 points are enough to know that we can draw a line. So I'm going to connect those points. But here's what we have to be careful of. It's a less than sign, not an equal sign. And with number lines, when we had a less than, we did an open circle. Well, we have to do an open line here. So to do an open line, we just kind of do a dashed line. And so we have to now shade one side or the other. We have to figure out which side to shade, where the solutions are at. Are they down here? Are they up there? It's a less than sign. That can give you a hint. Otherwise, test a point. Pick a point that's not on the line. Like 0, 0 is not on the line. Pick a point, plug it in, and see if it's a solution. So you have an x value of 0, a y value of 0. When you plug them in, 0 is less than negative 2 times 0 plus 3. Well, so we get 0 is less than, that's 0 plus 3 is 3. 0 is less than 3, that's true. 0 is less than 3. So 0, 0 is a solution. So everything on that side with the 0, 0, on that side of the line gets shaded. All points in that order, in that area, would be solutions. Okay, now let's try one that's in standard form. So negative x plus 2y is greater than 4. If you want to put in slope-intercept form, you can, or you can find your x and y intercepts. So x and y intercepts are ordered pairs. For the x-intercept, the y-coordinate is 0. For the y-intercept, the x-coordinate is 0. Plug those values in. So for the x-intercept, plug in 0 for y. So off to the side, when I do that, I would get negative x, and then 2y becomes 0, it goes away. It's greater than 4. I don't really care about this, the inequality. I can pretend it's an equal sign. Negative x equals 4, so x would be negative 4. So negative 4 is my x-intercept. And for the y-intercept, plug in 0 for x. Negative 0 is just 0, so I have 2y. It's greater than, I don't care that it's greater than, you can pretend it's equal. Right now where you're finding the intercepts, 2y equals 4 divided by 2, you get 2. So I found my x and y intercepts. So an x-intercept of negative 4, put a point. Y-intercept of positive 2, put a point. Go ahead and connect the dots. Notice it's not equal to, so I use a dashed line again. And then I have to test a point. Be careful using your sign saying, oh, it's greater than I automatically know. That doesn't always work when you're in standard form. Sometimes it does, sometimes it doesn't. So I would pick a point like 0, 0. Let's check and see if 0 is a solution. Plug it into the equation. I get 0 plus 0 is greater than 4, so it's 0 is greater than 4. Oh, 0 is not greater than 4. So 0, 0 is not a solution. That's down here on the underside, so we must have to shade up on the other side. So that's where our solutions would be. So those are some equations, both standard form and slope-intercept form. We can also do absolute value. We did absolute value in the last section, but now we're just doing inequalities. So let's try y is less than or equal to 2 times the absolute value of x plus 3. So from our last section, we should recognize that, oh, this shifted up 3. Maybe you even want to write this down. Shifted up 3, and then 2 makes it narrower, or the slope is going to be 2. So on my number line, go up to 3, put a point, and then it's a v, because it's absolute value. It's going to be open and up. It's going to be kind of narrow. Since that slope is 2, you can actually count it out. Instead of just drawing a narrow v, you can go up 2 and over 1. So you kind of have an idea of the steepness of the v. When you go to get the other side, you have to go to the left, but you can see what that narrow v looks like. Oh, I kind of got ahead of myself and I drew a solid line, but this time it was less than or equal to, so I should have a solid line. I kind of got lucky there. I didn't even think about it. Be careful. If you do happen to draw a solid line and you didn't mean to, go ahead and just kind of boldly shade over it, or draw a line to it saying that it was supposed to be shaded. Now I can live with that. Or if you're using a pencil, you can just erase. But this one was supposed to be solid, so I'm okay. Test to point. Either we're going to be shading inside of the V or everything outside of the V. It's going to be one of the two. So I'm going to try 0, 0. So 0, 0 is outside of the V. Plug it in. I get 0 is less than or equal to 2. Absolute value of 0 is 0 plus 3. So on the right side, I just get 3. 0 is less than or equal to 3. That's true. So 0, 0 is a solution, and it's outside the V, so therefore I should be shading everything that's outside of the V, nothing that's inside. That's where the solutions are located. All right, there's a quick overview of graphing absolute value inequalities and linear inequalities. There's more examples in the book if you need them. But good luck.